what we're going to do is we're going to look at lenses and how we can detect where images are produced in lenses. And what we have to understand is with lenses, they are just due to the refraction of light as it passes through the material that makes up the lens. And there are two types of lenses. Okay? One is a converging lens and one is a diverging lens. Okay? We focus or disperse the light by means of refraction. A converging lens or convex lens is one that's thicker in the middle, and more importantly, it brings all of the parallel rays of light to a focal point. The distance from the center of the lens and where the rays meet is called my focal length. Conversely, a diverging lens is a lens where it causes my rays to spread out as if they're coming from a focal point. So the distance from the center of the lens to where the rays appear to be coming from, that's called my focal length. And we're going to go through how we can do each of them. Now, because lenses go through two refractions, they go through the light that travels through a lens goes through refraction when it enters the lens and when it exits the lens. What we're going to do is we're just going to simplify our model. We're just going to show the one refraction that occurs at the center of the lens. Okay, so we have some terminology. Okay, again, we have a converging lens because it's thicker in the center. Okay, now the very center of the lens is called our optical center. We can have an incident ray travel, and when it hits our optical center, we're going to show its refraction. And for a converging lens, the rays will often refract so that they go through the focal point. Okay, we have our principal axis, which is a line that is perpendicular to the lens and goes through the optical center. Because light can go through the lens from either direction, we have two focal points, a principal focal point and a secondary focal point. My principal focal point is on the opposite side as where the object would be. So if I have my object over here, this would be my principal focal point because the incident rays would travel through the lens to there. If I moved my object to the other side, then they would switch. For a diverging lens, we have the same terminology. We have our optical center, or the center of the lens. Incident rays will travel and hit the optical center and will show their refraction from there. But whereas in a converging lens, they go through the focal point, in a diverging lens, they're going to appear as if they leave from the focal point. And so therefore, I would do a dashed line and then a solid line showing. Okay, so in a diverging lens, my object would be over here. My principal focus is on the same side as my object. Now, when we do images in lenses, there are 4 rays that we could use. Okay, any ray that is parallel to the principal axis, when it hits our optical center, will refract and go through our focal point. Any ray that travels through the center of the lens will continue on through as if it did not refract. Any ray that goes through my secondary focal point and hits the optical center will refract so that it's parallel to the principal axis. So now we can use these to determine where the image in a lens would be. Okay, so our first ray is parallel to our principal axis. It's going to hit our optical center and it's going to refract through the focal point. A second ray through the optical center of the lens will travel through as if it did not undergo refraction. And our third ray that goes through the secondary focal point when it hits the optical center will refract parallel to the principal axis. And where these 3 lines meet, that's where my image will be. Okay, let's take a look at a second example. any ray that is parallel to the principal axis will hit the optical center and will undergo refraction to the principal focal point. Any ray through the optical center will travel through as if it's not refracted. And any ray through my secondary focal point, when it hits the optical center of the lens, will undergo refraction, so it's parallel to the principal axis. And where the three lines meet, that's where my object will be. When looking at a diverging lens, we do the same basic lines. We just have to remember that my principal focal point is on the same side as my object. So a ray that is parallel to the principal axis will refract as if it came from the principal focal point. A ray that would go through the secondary focal point will undergo refraction, so that's parallel to our principal axis. And a ray through our optical center will travel unaltered. And just like before, wherever these three rays meet, that's where my image will be. So let's take a look at how we would find our images in a diverging mirror. So our first ray would come in parallel to our principal axis, and it's going to refract as if it came from our focal point. So I'm going to draw a dashed line connecting my focal point to where my ray touches my optical center. And I'm going to leave it dashed behind the lens on the same side as my object, and I'll make it a solid line on the opposite side of my object. Then a ray that would travel through, if it went through my secondary focal point, is I'll put a dashed line connecting that. I'll line up my ruler connecting them. It'll travel as if it's going to go to the secondary focal point, but when it hits the optical center, it's going to refract. It's going to refract parallel to the principal axis. And again, I'll extend this as a dashed line behind the mirror as well. And then a ray that travels through the optical center will continue unaltered in its path. So now we would be led to believe that my rays don't meet, because if I look at my rays on the opposite side of the lens as where my object is, they don't meet. However, the extension of the refracted rays do meet. And so they meet here. So my image would actually be on the same side of the mirror as the object. Let's take a look at one more example. Okay, a ray parallel to the principal axis will refract as if it came from the focal point, which is on the same side as the object. So just put in a dashed line and make it solid on the other side. And I'll extend it dashed from the same side. A ray that would go through my secondary focal point will refract parallel to the principal axis. I'm going to extend it back. And a ray that would go through my optical center travels through unaltered in its path. So where these three lines meet, that's where my object will be. So where these three lines meet, that's where my image will be.